So this problem is called cake leveling, and it's a problem B from a pretty recent Division 2 contest. And the premise is that you're given an array A, and each value in A represents the height of the height of frosting on a cake. And you can change the frosting on the cake by slicing off a part of the frosting and pushing that excess frosting to the value to your right. And the goal of this problem is for each of I equals 1 to n, you look at the maximum height all the frostings are for all values from 1 to I, the maximum height that the frostings can be, where all of the levels of the frostings from 1 to I are equal. So for example, in this problem, the answer array, the first index would be 4 because it by itself, all the heights have equal value. But then at this at this part of the question here where I is equal to 2, the correct answer is 3 because you can push off this part of the icing and push it onto the index 2, and this will make both of them have height 3. So the answer for the second index would be 3, and for the last index it would also be 3, where you don't have to change anything compared to the second index because this value is already 3 and all the values from 1 to I will be equal. So the first thing to realize about this problem is that the answer for the index at I can never be greater than the answer for index at I minus 1. And this is because you can't move the layers of frosting to the left, and therefore the answer at I minus 1 will be locked in, and the only thing you can do at answer I is either use this answer for the previous index or create a new answer. And the next thing we realize is that the answer for I is equal to the minimum of the answer of I minus 1 compared to the floor of the sum of all values from I equals 1 j is equal to 1 to I of height j, and all this divided by I. This is just the average of all the values from 1 to I, but it just looks more complicated, but just know that this is the floor of the average of all the values from 1 to I. And this, as we established, the answer for I can never be greater than the answer of I minus 1, so therefore we have a minimum here. And we reason this out by knowing that for each value that is smaller than or uh, for each value that is greater than this average, we can push that part of excess layer of cake to the value to our right. And because the minimum is the answer of I minus 1, we then realize that it doesn't really matter if there's no case where the first value is smaller than the average, and we use because if that value is smaller than the average, then our answer will already be equal to at most that value. So we don't really have to consider that case, and we can just consider the average of all the values from 1 to I. So now we can kind of look at the code for this question. And basically, you just insert in all the values and you create the vector for answer, and you first push back the first value because the first value, the answer for the first index will always be equal to the first value because all the values from 1 to 1 will obviously be the same because there's only one value. And from here, we can use our solution, our formula that we made, where we calculate the current running sum, and then we find the current answer, which is the minimum of the answer of the past index with compared to the average of all the values. And I don't put a floor function here because C++ averages all doubles or decimal points down and never rounds it up. So I can just do this. And now I just print out my answer and the solution is complete. And you can see my submission right here is the same thing. And I'll probably put the code in the description. And I'm going to talk about C1 tomorrow.